Hi everyone, today we are going to discuss the chemical properties of alkenes. First, let's discuss the reactivities of alkenes. As we know, in alkenes contains of carbon-carbon double bonds. In this carbon-carbon double bond, they have a higher electron density between them. Thus, this site is called a nucleophilic site. This nucleophilic site is susceptible for electrophilic attack. Therefore, the alkenes can undergo the electrophilic addition reactions. Alkenes can undergo electrophilic addition and oxidations. There are many reagents that can be used for electrophilic addition of alkenes. For example, the hydrogen with a presence of platinum or nickel or the palladium as a catalyst. The product form involves the addition of hydrogen atom to the carbon-carbon double bond. Besides that, the alkene also can react with halogen in the presence of inert solvent. The product involves the addition of the halogen atom to the carbon-carbon double bond. Alkenes also react with halogen in the presence of water or halogen in aqueous solution. The product involves the addition of the halogen atom and the OH atoms. Alkenes react with hydrogen halide to form haloalkenes. The addition of the hydrogen atom and the halogen atoms to the carbon-carbon double bond will follow the Markovnikov rules. Alkenes also react with acidified water to form alcohols. The addition of the hydrogen atom and the OH will follow the Markovnikov rules. Finally, the alkenes react with HBr with the presence of peroxide to produce the haloalkenes that follows Anti-Markovnikov rules. How to determine which carbon atoms in the carbon-carbon double bond will attach with the hydrogen atom in the hydrogen halides? To determine the product of this reaction, we can follow the Markovnikov rules. What is Markovnikov rules? Markovnikov rules states that in the addition of hydrogen halide to the unsymmetrical alkenes, the hydrogen atom in the hydrogen halide form a bond with the carbon atom of carbon-carbon double bond with a greater number of hydrogen atoms. And we also can apply the Anti-Markovnikov rules. The Anti-Markovnikov rules states that in the presence of peroxide, the addition of HBr to the alkenes follows anti-Markovnikov manner. That is, the hydrogen atom of HBr form a bond with the carbon atom of the carbon-carbon double bond with fewer number of hydrogen atoms. The first example of the electrophilic addition of alkenes is the reaction of catalytic hydrogenation. The reagent involved in this reaction is the hydrogen gas in the presence of catalyst of platinum or palladium or the nickels. Let's say we have an example of propene. When propene reacts with hydrogen in the presence of platinum, the product form will involve the addition of hydrogen atom between the carbon-carbon double bonds. The next example is the halogenation in inert solvent of CH2Cl2. The reagent used in this reaction is the halogen and the CH2Cl2 as the solvent. If we have an example of propene, when react with bromine in the CH2Cl2, we will produce a dibromopropane, which is involve the addition of the bromine atoms to each of the carbon-carbon double bond. Next is the halogenation in water. The reagent used for this reaction is the halogen in the presence of water. Take note that the halogen atom is added to the carbon atom of the carbon-carbon double bond with more hydrogen atoms. For example, when we have a reaction of propenes with bromine water, the product form involves the addition of the bromine atom to the carbon-carbon double bond with more hydrogen. The next example is the hydrohalogenation. The reagent used in this reaction is the hydrogen halide. To determine the product of this reaction, we'll follow Markovnikov rules. For example, when we have a propene react with HBr, the addition of the hydrogen atom will involve the carbon-carbon double bond with a greater number of hydrogen atoms. The next example is the reaction with acidified water. The reagent used in this reaction is H2O with acid catalyst. The product will be determined by following the Markovnikov rules. For example, when we have a propene react with acidified water, it will produce an alcohol. The addition of the hydrogen atom will involve the carbon-carbon double bond with a greater number of the hydrogen atom. That gives a major product. The last example of electrophilic addition of alkenes is the hydrohalogenations. The hydrohalogenation of HBr in the presence of peroxide will follow the Anti-Markovnikov rules. For example, when we have a propene react with HBr in the presence of H2O2, it will give 1-propanol, which is the reaction involves the addition of the hydrogen atom to the carbon-carbon double bond with less number of the hydrogen atom. That gives a major product. Alkenes also can undergo the oxidation reaction. There are many oxidizing agents that can be used to oxidize the alkenes. The first reagent is a cold dilute potassium permanganate in alkaline solution. This reaction will produce a glycol and the manganese oxide. The second reagent is the hot potassium permanganate in acidified solution. The reaction will produce a carbonyl compound. And the third oxidizing agent is ozonolysis. The reagent used in a two-step reaction which is involve ozone and the hydrolysis with zinc in H2O. That will give a product of carbonyl compound. The oxidation of alkenes with cold dilute potassium permanganate in the presence of OH- is called Bayer's test. This test is used to identify the presence of carbon-carbon double bond. From this reaction, we produce a glycol and the brown precipitate of manganese dioxide. The next oxidation of alkenes is the reaction with hot acidified potassium permanganate. This reaction is also can be used to determine the position of carbon-carbon double bond. For example, if we have a propene to be oxidized with hot potassium permanganate, it will produce a carbonyl compound as a product. But the product form is determined by the type of atom bonded to the carbon atoms of carbon-carbon double bond. The product formed from the reaction with hot acidified potassium permanganate is determined by the atom bonded to the carbon double bond. For example, if the carbon double bond is bonded to two hydrogen atoms, it will produce the carbon dioxide and water. But if there is only one hydrogen atom bonded to the carbon double bond, it will produce a carboxylic acid. Otherwise, if the carbon double bond only bonded to two alkyl groups, it will produce a ketone. These equations shows an examples of the product form when alkenes oxidize with hot acidified potassium permanganate. Alkenes also undergo ozonolysis. The reagent used in this reaction is the ozone and followed by hydrolysis with zinc in H2O. This reaction is used to determine the position of carbon-carbon double bond in an alkenes. For example, when we have a propene react with ozone and followed by hydrolysis, we will produce a carbonyl compound. Now, let's discuss the unsaturation test of alkenes. The unsaturation test is used to distinguish between the alkanes and alkenes. For example, the Baeyer test. The Baeyer tests are using a cold dilute potassium permanganate in the presence of alkaline solution. From this test, we can observe that the alkenes decolorize the purple color of the potassium permanganate and give a brown precipitate, while in alkene, the purple color of potassium permanganate is remain unchanged. The second chemical test that can be used to distinguish between alkene and alkenes is the Bromine test. In this test, we can observe that the alkenes decolorize the reddish-brown color of the bromine, while the alkenes, the reddish-brown color of the bromine is remain unchanged. We also can use the bromine water as a chemical reagent. From this reaction, we can observe that alkenes decolorize the yellow-brown color of the bromine, while the alkenes, the yellow-brown color of the bromine water is remain unchanged. That's all for today's lesson. Thank you.